Okay, we'll get started here. Good evening, everyone. Thanks for joining us. Really excited to have you here to learn a little bit about our Master of Advanced Studies programs that we offer through the Jacobs School of Engineering. Next slide, please, Yvonne. Next slide. So I'm going to get right to it. We have a lot of good information about the programs. I'm just going to take a few minutes at the beginning to give kind of an overview of the MAS programs as a whole. And then we will have Dr. Ryan Kastner and Dr. Fred Harris available to talk about the Wireless Embedded Systems program. And then we'll have Professor John Wade and Professor Hal Sorensen discuss the Architecture-Based Enterprise Systems Engineering program. And finally, the Data Science and Engineering program with Professors Aline Deutsch as well as Ilke Altintas. And we'll talk a little bit about next steps and then have joined us and get some first-hand answers to your questions. Next slide. So my name is Gary Henderson. I'm the Director of Engineering Executive Education. One of our responsibilities is to administer the MAS programs. You'll see some of my staff here. Yvonne Wu, who you'll hear from shortly, is the Assistant Director of the MAS programs, as well as the Program Manager for the DSE and West program. Many of you, if you've started your applications already, have had an opportunity to work with Yvonne, as well as Stacy Williams, a Program Manager for our Architecture-Based Enterprise Systems Engineering program. Kristen Lil-Jestrom is here as well, taking care of our operations and our administration, as well as Sage Longpre. She can't join us tonight, but she works alongside with Kristen and is responsible for fiscal operations. So as we said, the MAS programs are offered through the Jacobs School of Engineering. As many of you know, Jacobs School of Engineering is one of the largest in California among public universities. This year, we're ranked 10th top engineering school in the nation by US News and World Report, with an active research faculty larger than 275. And with a strong commitment to serving the needs of industry for latest in research as well as education. And the MAS programs bring all of that together for working professionals. You can see more rankings about all of our departments and more, but I won't spend too much time on that. Next slide, please. And the Master of Advanced Studies are not unique, but really driven by partnerships and collaboration. These are really interdisciplinary programs working at the intersection of lots of units and departments across campus. We've mentioned a few here, but this slide could get very large if we added research centers and all the other partnerships that go into creating these MAS programs, teaching in them, and ensuring that we have the most up-to-date and relevant information for our students. Next slide. That collaboration also spans with companies. We have over 200 companies represented in our programs, and the MAS programs really strive to ensure that they're relevant, not only to the student interests, but also for their career tracks as the working professional engineers progress through their organizations. And oftentimes we get asked what the Master of Advanced Studies degree really is. And it is a master's degree conferred by the UC San Diego. It's the same stature as every other degree. Many years ago, the University of California came up with this distinction. Many of you may be familiar with the Master of Engineering degree, which is very similar. The primary distinction being MS degrees typically, though not always, are really focused on research, whereas the Master of Advanced Studies, as well as Master of Engineering degrees, as well as many other degrees that are coming out nowadays, are really focused on the needs of companies and engineering and technical professionals that are working in industry right now. These are professional degree programs, really tailored to working professionals. They're also interdisciplinary, as I mentioned before, focusing on areas of emerging technology, as well as new fields that traditional curricula don't always address. And at this point in time, we offer 3 programs, the AESE program and the WEST program and the DSE program. I just note there that there are more in development, and many of our faculty working with companies to establish new degrees that broaden the scope of working professionals that we can serve. So one of the unique things about MES programs specifically is, as I mentioned, these are really designed at the heart to meet the needs of engineering and technical professionals. Some of them are focused on areas that students are best served with several years of professional experience. Others, you know, a few years of working experience and the knowledge of the career tracks within the organizations and how they can succeed in those. And they're designed to address the skills that are most needed today and deliver integrated interdisciplinary knowledge. And everything from the bottom up is optimized for working professionals, the schedules, how we serve the students, et cetera. I'll provide just a brief overview of the general admissions requirements, but before I get to this, it's important to note that the admissions committees take a very holistic approach to reviewing applications. And so we realize that many of our students have been out of work for many years, if not decades. And it's important to note that while we have basic standards, each program can have its own unique standards, and the program summaries that are coming next in this presentation will go over some of those in more detail. But just know that oftentimes working professionals need exceptions for things, and if you're the right fit, and that's what the admissions committees are focusing on, is fit. Is this relevant for you? Will this help you in your career? And can you succeed in this program? Those are really the primary criteria, and the rest are opportunities for you to showcase those skills through your application. The program schedule just shows that each of the presentations that are going to come are going to be much more specific, and so this should just be thought of as an overview. Just to give you an idea of the length, the AESE being a 1-year full-time program, and the WEST and the DSE programs taking 2 years to complete. And so this will give you just kind of a broad stroke overview, and we'll get into some more of the details in the presentations that follow. Program costs, we have the program costs for each program listed there. The important thing to note is this is an all-inclusive tuition cost. So you have your tuition, plus you have mandatory UC graduate student fees that are charged to students, but everything's included in those tuition costs. Your course materials, software and hardware that you need, computing accounts, parking, meals, etc. So we try to be as transparent as possible and show you the full cost up front and let you know what you're getting. This does not include a mandatory health coverage of about $3,500 per academic year. We don't include that because our students are working professionals or otherwise have insurance, and we typically work with students to waive those fees. And so the last little disclaimer that I should mention is every year we go through a review with the University of California Office of the President to review what our tuition is. And though these are our estimated costs based on what we've have charged, and we'll see in a few months here if the University Office of the President agrees with us or not. But typically what we've tried to do is keep this affordable, accessible, and really focus on making it the best value possible. That's what I wanted to cover tonight as just kind of an overview of the MAS programs, but I would refer you to our website for all of the programs. If you go to this website, which I'm sure many of you have already, you can see all of the information for each program, including the curriculum, the faculty, the admissions requirements, costs, etc. And so I really encourage you, if you haven't already, take a look at those and those resources, and certainly reach out to us, myself, Yvonne, Stacy, and any of the faculty at any time. I think you'll find that the faculty are extremely accessible and here ready and willing to help. So in the interest of time, questions will be answered in the breakout rooms. We'll try to get through each of these in about 10 to 15 minutes. And then we have plenty of time scheduled for questions and answers in specific breakout rooms for each of the programs. So with that, I'll turn it over to Dr. Ryan Kastner and Dr. Fred Harris.
Okay, my video is not working, but I will figure that out in a second. Go ahead, next slide, Yvonne, please. So, this program is the Wireless Embedded Systems program, and it's a program. So, as Gary said, all these programs span across multiple departments or institutes at UCSD, and this one is spanning across the computer science and electrical engineering department. So I'm a professor in computer science and engineering. And Fred, there I am, hello. Fred is a professor in ECE. And so, all the way from the directors, we strive to make this program something that is interdisciplinary and, serving kind of unique student needs and unique industry needs in the local area. So typically our students either have a background in computer science or electrical engineering, one or the other. And so we deal with that mix of students in different ways. And I can talk more about that in the breakout session. It's a 2-year program, basically full on pretty much for 2 years, and articulating a number of different courses that we have in both programs. So go ahead and go to the next slide, please. So the motivation for all of this, and maybe a reason why you might be interested in this program, is just the proliferation of IoT devices, so Internet of Things devices. And so if you look at this chart, this is a marketing chart, but it serves the kind of the big picture of what we're aiming at with this program. So just the sheer number of new IoT devices. So this is not even including laptops or smartphones or other sort of more traditional computing devices is growing at a phenomenal pace. So we'll have 21.5 billion IoT devices in a few years from now, if these predictions hold, right? So a few devices per every person in the world, right? So it's pretty staggering. And you can see that most of these devices are not wired, so they're wireless. So using different types of wireless communication, 5G, typical Wi-Fi, low power wireless area networks, and other devices like that. And that's really what we're trying to target in this program, is the ability for you to understand how to develop on these devices and how to use these devices and how to open up new application areas for these different devices. Next slide, please. So, where do we use these? We use these kind of everywhere. So computers are everywhere. And wireless embedded systems are also everywhere. So, in our cars, there's 100 microcontrollers or more in modern cars. in industry, in our cell phones, in our laptops, in all the devices, in our refrigerators, our toasters, our washing machines. Everything has computers these days, and almost all of those have some aspect of wireless computing in them. And then we also have a big infrastructure sort of at the edge, and these are the the 5G cellular networks or the 4G cellular networks, the base stations that are servicing all of these these demands, right? There's we talk a lot about that, and of course there's a ton of work in the cloud and the data center. So how do you design these devices? How would you go about these? Well, it's a huge problem. It's a huge system design problem with a large number of different trade-offs. Performance, how fast you can do things, how much they cost, how much power they consume is a huge issue. And it also spans software and hardware. So it expands across computer science. It expands across electrical engineering and computer engineering. So really you kind of have to have knowledge and expertise in a lot of different areas if you want to be an innovator in this space. Next slide, please. So that's what we're trying to teach you in this program. So how would you develop new applications on these emerging devices? This is a visual layout of our different classes and the different topics that we'll cover in those classes. So on the left, we have the more traditional kind of computer science, software, computer engineering classes, I would say. So those are largely focused on embedded systems. So how do you program these devices that aren't, your traditional laptops or expect user interactions? They're very different and have energy constraints and all kinds of just really hard problems to solve there. How do you write software for them? How do you develop hardware for them? And then on the right is more of the kind of traditional electrical engineering topics that you would see maybe in an electrical engineering master's program. So how do you transmit information across a wireless system, across the air? What sort of signal processing do you need to do on that? What does filtering mean? How do you build up filters and estimators into more complex digital systems? And then ultimately build something like 5G, which is just insanely complex and requires a huge amount of computation in order to make a reality. And so topics in all those classes, and we kind of mix all those classes together over the 2 years. And at the end, and actually throughout all the classes, we take a big focus on prototyping of these systems. So using modern boards, embedded systems, GPUs, FPGAs, software-defined radios, using modern design tools from Intel and AMD and Xilinx and MathWorks, and all the different kind of tools that you would see in a commercial space if you're working at a company like Qualcomm, or if you're working for the Navy, or if you're working for Northrop Grumman or Cubic, or all the different companies that we've had students in over the years. Next slide, please. So this is a more textual sort of table layout of the classes. And the big takeaway here is that we have, we tried to evenly distribute these classes to make the process manageable. This is a real master's degree, and this stands up to any of their master's degrees in either the departments. So doing that while also working full time is a challenge, and we do our best to kind of make that happen. And one big way that we've heard over the years, over the decade that we've been doing this program, is that not to try to overwhelm people, and that we do our best to do that. So the first year is just one class at a time, kind of mixing between electrical engineering, signal processing, embedded systems, signal processing, embedded systems. And then in the second year, we have a couple challenging quarters that are classes in both sides, so 2 classes. But the classes are work together in order to make them sort of again manageable, and the projects are related, and all throughout you're working on with real software, with real hardware, with just really interesting devices that companies are using today. And at the end, the big capstone project. So actually the last 2 quarters we focus on that capstone project. So taking all of your skills that you've learned over the year and a half and developing a project of your choosing that we guide you on, and building up something, a wireless embedded system that demonstrates all this knowledge, and something that you can, go back to your employers and say, here's what I've learned. You can, maybe tell your families, here's what I've been doing for this past 2 years. But again, taking a real hands-on approach to demonstrate and teach these skills that you need. Next slide. I think that's it for me. So Yvonne, you can take it away.
Yes, so I'm going to go over the general admissions requirements. I am the program manager for the West program, so if you guys have any questions, feel free to reach out to me. As Gary had mentioned previously, these are just general admissions requirements. There's definitely exceptions that can be made, but each program has slightly different admissions requirements, so I'll just go over a few of them briefly. A bachelor's degree in engineering, science, physics, mathematics is preferred, but not a requirement. It is a university requirement for a 3.0 minimum GPA, but again, we have made exceptions in the past. It depends case by case. As Gary had mentioned, the admissions committee will look at the whole application and everything you submit and just to see if you are a good fit for the program. So I typically work with them and the graduate division to get you admitted if they would like to nominate you for the program. What else is included in the application would be a statement of purpose, 3 letters of recommendation, a resume, and if you've had at least 2 years of work experience, then the GRE is not required. You're more than welcome to submit it if you have it, but it's not required if you have the work experience. And another thing that we waive is if you have English proficiency requirement, that gets waived if you've worked in the US for at least 1 year. So those are the general admission requirements for WES, and we will go into the next program. But first, again, a reminder for in the interest of time, questions will be saved until the breakout rooms after all 3 programs have presented. So now I will hand it over. We will go over the architecture-based enterprise systems engineering leadership program. We have both faculty directors, Hal Sorensen and John Wade here, but I believe John Wade is the one presenting, so I'll hand it over to you, John.
Thank you, Yvonne, and thank you, Professor Sorensen, and thank you, everybody, for attending today. This is going to be shifting gears a little bit, and rather than talking primarily about technology, we're going to be talking about the enterprise and enterprise systems engineering and leadership. This program is really focused on developing systems thinking capabilities and skills and architectural skills that incorporates and looks at the entire enterprise. The enterprise landscape, enterprise stakeholders, enterprise goals and missions. It's a joint program between the Jacobs School of Engineering and the Rady School of Management. And so you'll be learning quite a bit, both on the technical side and also on the managerial side. There are 2 of us who are directors, as had been mentioned, Dr. Hal Sorensen, who created this program, and created it really to address many needs that he'd seen within industry, which were true then and are certainly true now. And the fact is, even if you have the best technical people together and have amazing technical solutions, success is really based upon the ability for that solution to serve the entire enterprise. The audience for this program are engineers with 5+ years of relevant professional experience, who are really looking to be in a position to drive enterprise systems and to take on leadership positions within their organizations. As has been mentioned, this is a 1-year program starting in September and ending 12 months later. It's on alternating Fridays and Saturdays, plus there's a 1 4-day workshop per quarter. Next slide, please. So as mentioned, this is an architecture-based enterprise systems course, and it's really focused on systems thinking and leadership. As mentioned, it's a joint program between the Rady School and the Jacobs schools. And what's critical about this is really understanding the entire problem at hand and all the different pieces that are required for it to be a successful solution. I usually think about an example of systems thinking as sort of Steve Jobs, when you think of the iPhone. You have to be really a great engineering company, manufacturing company to make millions of these every month of high quality. Design thinking is important so that you have the right user interface. But the thing that made the iPhone really so successful, and Apple, the most highly valued company on the planet, is the systems thinking side of things. And Steve Jobs realized that the reason people want smartphones is they want them for content and they want those for applications. And so he created an ecosystem to build applications and all the different connections through iTunes with respect to content. And it's those aspects that we're really looking at in this program, which is, what is the real value that you can find in your system, and what are all the different parts that need to work together to make that real. Next slide, please. So we're really focusing on the integration of lots of different, previously maybe unconnected systems and capabilities. And the acceleration of these processes has just gone off the map with the digital transformation, with the availability of low-cost computing, with the availability of data, which has been mentioned by Professor Kastner, and artificial intelligence and machine learning that allows you to pull all these things together. All these different components allows you to create organizations with your enterprise that are quickly learning organizations. And if you look at, some of the most highly valued companies on the planet, the Alphabet Googles, the Microsofts, the Amazons, the Apples, they're all corporations that have figured this out, that really understand how to instrument their organization, their enterprise, and to learn quickly. And so if you look at it, the server farms, the internet, the digital capabilities, mobile devices, cloud, big data, AI, and machine learning, it's pulling all these pieces together, which is really what this program is focused on. Next slide, please. So looking at the curricula, in the fall, you're going to be learning about leadership. You're going to be learning about yourself. You're going to be learning about how you actually interact with others. It's interesting, we did a survey recently with the corporate affiliates program here at the Jacobs School, and the largest gap that they found for new college grads and also for mid-career engineers was in the area of interpersonal skills, communication, and leadership skills and such. And so we focus on that. Also, we're looking at systems thinking, looking at the big picture. What is the real problem that you're trying to solve? What is that environment and what does that landscape actually look like? In the wintertime, we start focusing in on the architectural frameworks. What are the different technologies and architectures that people actually use in their enterprise to pull their systems together? So in the fall, we look at the problem, and in the winter, we start looking at the concepts for those solutions. And then in the spring, focusing on decision systems, what's the art of decision making? How do you create these systems that are going to be able to sort of learn over time? And we use a number of different technologies, concept maps, planning tools, use case, UML, SysML, data analytics tools, cybersecurity tools, and all the like to pull this together. There's a project that threads through all of this. And so you will be working on teams. It's very much a team-oriented program, and your teams are going to pick up a problem and work through that problem through the entire course, through the entire program, I should say, and it works and threads through all the courses. Next slide, please. Our learning model is really one of interaction. You're going to learn probably 10% of the material in the classroom, and the way things are usually set up is you'll go into the classroom, you'll hear some lectures. And then you'll be working with your teams, and we'll be providing mentoring and coaching and the like. But your team project is really going to supply you with the experience, essentially an on-the-job experience for the skills that you're going to be learning for this. And that's where much of the work is going to be. So again, this is really focused on team projects and that sort of things. As noted above, enterprise systems and systems of systems are complex adaptive systems. And so these are systems that you are going to learn on. They're not systems that you can figure out and come up with a deterministic solution, but actually they're systems in which you're going to be creating and running some experiments and developing systems that will be able to learn. Next slide, please. So what are some of those capabilities? Understanding the enterprise, understanding that landscape, interacting with enterprise stakeholders. It's critical that you're able to interact with actual people to understand, what their job is about and how they actually create value. You'll be defining goals and missions, creating strategies, operational concepts, determining what the desired capabilities are going to be, for your particular system, developing those architectural models, verifying those, validating those, and then iterating through this process. And going through this process will give you all the tools that you really need to be leaders and team builders within your enterprise. Next slide, please. So again, the delivery, it's a one-year program. This classes are scheduled on alternating Fridays and Saturdays. There's one Wednesday, Saturday workshop per quarter. The classes start at 8 a.m. They end at 5 p.m. When they're on campus, which hasn't been for a while, breakfast and lunch is provided. The classes are offered sequentially, and the classes have been developed to be offered sequentially. So one course fits on to the next course, and they work smoothly with respect to your project. Each class has 32 contact hours, 8 hours in 4 days, and then there's that final 4-day team project. Next slide, please. I'll hand it over to you, Stacy.
Thank you, John. So I'm Stacy. I do manage the AESE program. So if you do have any questions about what you heard from John or anything I present here, please don't hesitate to reach out to me. My email's on the under my photo here. So I will piggyback off of what Yvonne and Gary mentioned about admissions requirements. They are requirements to an extent, but we are able to get exceptions for things if your application is strong in other areas to make up for areas where you might not have that 3.0 undergrad GPA from 20 years ago, right? So we do ask that you do have a bachelor's degree in some sort of technical field, so engineering, science, physics, math, but we have had people who have been incredibly successful in the AESE program who have had degrees in music or a foreign language, but have otherwise worked in a technical capacity for many years. So work experience, I think, for the AESE program really kind of makes up for a lot of the requirements here if you're lacking. So the 3.0 minimum undergraduate GPA, that is a UCSD requirement, but we can get you a letter of exception if you're lacking that. A statement of purpose, it should be informative, really explain what you would like to get out of the program, what you would like to contribute to the program. Maybe think of a project that you're interested in working on. We like to see at least 2 letters of recommendation. 3 are good, but 2 letters are preferred, and they should come from somebody in a supervisory role. 5 years of relevant work experience is something that we also look for, but if you have less than that, but you have some sort of really stellar work experience or other experiences that you can add to your application, please do include that because it's not a hard and fast rule. Your resume should be informative, and then like the other programs, we don't require the GRE if you have at least 2 years relevant experience, but again, that's also flexible. And so in the interest of time, please do hold your questions. And next will be Dr. Ilkay Altintas, and she'll present on data science and engineering.
Welcome to the info session. I'll present the data science engineering for Professor Alin Deutsch and myself. So the data science engineering is going to be in its 9th year over the next year. And it's designed for professionals with a background in a technical program, computer science, engineering, mathematics, or other related data analysis fields. And courses run over 2 years. It's a 2-year program with classes alternating on Fridays and Saturdays every other week. So next, please. Why did we even create this program, and why are we talking about data science now when data existed for a very long time, right? I always say, I don't want to say data, but it's the data. We, as you've seen in the previous presentations too, through many different technologies, we generate a lot of data as the society, science, and many other applications. And the data itself comes from very different sources with high complexity. But more importantly, traditional methods to analyze data and, so to say, to generate value from it doesn't scale anymore. And this often gets referred to as big data, which is data that we define with a lot of complexity and a lot of variety, which comes from different sources and things related to challenges related to its volume, how big data is, and its complexity. And within the program, we teach techniques to turn data into insight through methods that span various areas. First of all, data has to be engineered. That's what data engineering comes from, to be in a form that's useful for analysis. And data science techniques and visualizations and different types of communication techniques need to be applied to it, so we can actually turn these analysis results or insights, which are themselves data products, into valuable bits or into things that can be a part of data products. What's a data product? It's everything that you're using in your cell phone and the social media. Everything actually is designed around some data that, for instance, why is my smartphone smart? Because it can sense the environment, turn that into data, or it can actually work with data and communicate that. So I think you've seen in previous presentations also some aspects of how this data comes together. Next, please. So then who is a data scientist? What kind of skills do we need to turn data into insights and value at the application scale? I think it's a set of skills that doesn't exist often in one person, but we can understand the breadth of these. So when we look at these skills and techniques, we are looking at substantial math and statistical knowledge, and hacking skills, which is like programming, and also combination of these skills with expertise in a domain area, or with an ability to understand domain-specific problems and have the culture to work with teams in various application domains, different business domains, so we can actually solve problems through these hacking and math skills. And hacking skills, of course, include data engineering. As I mentioned, that's a part of our ability to actually turn data at scale into useful bits for analysis. Then we can also use scale. So computing is a part of this, because part of having loads of data, as we talked about, and big data, is being able to actually turn the methods we have into scalable programs that we can then build into products that build on the strength of these methods and scalable programs. Next, please. So what we provide in the program towards this is, as I mentioned, it's a 2-year program, and the language of choice in our program is Python, because it's at the moment the most popular data science programming language for data analysis and scalable methods and visualization. And it builds on a open source community of developers that build into Python. So people like you and me and us are actually continuously developing into Python as an open source product. So it becomes, it evolves over time to meet the challenges of that moment. And we also combine this with, again, courses in the year 1 in data management, data engineering, and also probability and statistics skills, which turns into a foundation for machine learning and scalable analysis courses. And we build on these in year 2 with data integration and more like a NoSQL beyond relational data modeling courses and visualization to communicate the results. And we end with a 2-quarter capstone design project that's built on a real life problem with real dirty data sets, working with advisors in different domains. So we take pride in actually making these capstone projects a learning opportunity for what you didn't get in the program, but also to make them really related to a real work in a scientific lab or in a business that we work with. And there's definitely a capstone faculty member which coordinates this, which is generally me, and also project advisors who are experts in a combination of a domain area and in data science. So they could actually be the guide for more learning from the faculty that you didn't have in the program often. And we have also a part of our program, which is about case studies. So we have, every time the class meets, we have an hour of a presentation, a seminar by a professional who works in data sciences. And they talk about what they do and how they use data sciences and engineering in their professional work or in their research, if they are UCSD researchers. Next, please. So that brings us to the admission requirements, which I'll pass the mic to Yvonne. Thank you for listening.
Thank you. Okay. So I'm also the program manager for data science and engineering. So I'll briefly go over the general admissions requirements for this program. It's a lot like the other two programs with, again, slight differences. The bachelor's degree is preferred for engineering, science, physics, math, but of course we have accepted, many students with a variety of backgrounds. I think with this program, I've seen the most variety when it comes to background, so, or with their undergrad degree. So definitely varies for this program. A 3.0 minimum GPA, again, it's a university requirement. The application asks for a statement of purpose. 2 letters of recommendation are required, but 3 is preferred. We do ask for a resume, and again, the GRE is waived if you have at least 2 years of work experience, and we will also waive any English proficiency requirement if you have that, if you've worked in the US for a year. There is another slight difference with the DSE application. On the application, it does ask 6 data science related questions. It pretty much asks questions to gauge more on your data science experience. If you have any experience with programming, with database systems, if you have a good math foundation. So with that, this is where this additional requirements comes in. Major importance, they look for at least 2 out of 3 of these. As I mentioned, the programming experience in general purpose language, experience with databases or SQL, experience with data analysis in an application domain. They also, look at your math foundation so that it has minor importance, but it does help strengthen your application. So they're hoping that you've had linear algebra, probability and statistics, and that you have worked with distributed systems like Hadoop and Spark. Again, this is showcased in your response or your answers to the 6 additional data science questions that are asked on the application. So that concludes the 3 programs. Again, we asked you to save all your questions till the breakout. So the next step is we will go into the breakout rooms. But first, really quick, just an overview. As Stacy and I have mentioned, feel free to reach out to either one of us if you have any questions about any of our programs. Again, I manage the DSE Data Science and Engineering program, as well as the Wireless Embedded Systems program. And Stacy manages the Architecture-Based Enterprise Systems Leadership program. You can find most of the information that we provided here on our website. Applications are now open. Each program does have its own admissions page with all the admissions requirements. Our deadline is May 4th. If you have any additional questions, definitely ask us in the breakout rooms, or you can always email us, contact, Stacy or I if any questions pop up after this info session, or while you're going through the application process. If you have any questions during that, we're more than happy to help answer those questions. So we will open up the breakout rooms so that you can pick which program you want to go into, and you'll be joined by faculty directors, program managers, and hopefully alum in the breakout rooms for further discussion where you can ask questions. So give me a second and I will get those open.